Welcome there. Today we are going to talk about extrema. And extrema is nothing more than a fancy word for the plural of extreme. So if you have more than one extreme, you have extrema or extrema. Extrema are just maximums and minimums. You guys know what maximums look like: the tallest thing, the biggest thing, whatever. Minimum, smallest thing, lowest thing, whatever you want to call it. Graphically and in math, you can define it, in the math notation here. F of c is a maximum, so c is the x value, all right, f of x. C is replacing that. C is some number on the x-axis that's part of the function, such that if you plug c in and you get a number bigger than every other x, then f of c, the y value, f of c, will be the maximum value. And similarly, f of c is a minimum if for every f on the interval, if f of c is less than or equal to f of x. Notice the or equal to. This implies that you can have more than one maximum or more than one minimum. Okay, so a quick diagram here of something like that. If I do just a little wavy guy like this, this point right here, and we'll put that in blue, if this is some value, we'll call it c, then f of c is greater than all other values of f of x. So that is a maximum value, and that occurs at f of c, c comma f of c. Okay, and likewise, let's call this guy c sub 1. Okay, f of c sub 1, whoops, sorry, let's go down here, got the wrong spot. Right here is the lowest point, we'll call that c sub 1. F of c sub 1 is less than every other point on this graph. Okay, so these are strictly less thans or strictly greater thans. However, they could be or equal to's, and that would be okay also. Okay, that would just mean you'd have more than one. Think of a sine or cosine curve. They have several maximums. Oftentimes crosses at 1. Oftentimes it's at -1. They're all maxes slash mins. All right, so extreme values or extrema. If you're on an interval where something's called a maximum or a minimum, it is assumed that they are absolute maximums and absolute minimums. They are synonymous with each other. All right. A lot of these definitions you can read through. I'm just trying to give you a quick explanation of what these math words mean. The extreme values theorem says that if you have a continuous function, recall we have 3 criteria for continuity. The limit must exist at some point c, the function at some point c must exist, and those two values must be equal. So if you have a continuous function on a closed interval, you are guaranteed to have both a maximum and a minimum on the interval. Remember, max and min are synonymous with absolute maximum, absolute minimum. All right, so think about it. If we have 2 points, I'll put 2 points anywhere. And this is a function, right? It's a function if f is continuous. If the function is continuous. So I'm going to try to connect these such that it's a function. All right, so they're connected. I could have done lots of different things, whatever, as long as it passes the vertical line test. It says I'm guaranteed to have an absolute max, there we go, and an absolute min, there we go. There's no way to connect them such that that is not the case. It is possible for the endpoints to be your absolute max and mins, okay? Keep that in mind as well. The relative extrema. So a relative extreme is something that relative to that area is a max or a min. So if I'm looking at a graph that looks something like that. We'll put open circles here. If I'm looking at a graph like that, this, pretty close. This is going to, it might be an absolute, depending how to scale this is, but we'll call that relative. It looks like it's a little bit lower than something over here. That's a relative max. This is also a relative max because it's the top of the hump. This is a relative max, top of the hump. All right, and likewise, this is a relative minimum because it's the bottom. Relative minimum, the bottom. Relative minimum, the bottom. All right. One thing I think you're starting to notice here is, especially with the relative extrema, they always occur at tops or bottoms of graphs. And tops and bottoms of graphs occur when tangent lines, when derivatives are 0, right? A derivative is the slope of a tangent line. So they occur when tangent lines are flat. In other words, have 0 slope. They're horizontal. All right, so the definition of a critical value or a critical number can also be a number there. If you have a function that's defined at some point c, such that when you take the derivative and plug in c, you get 0. That's a critical value or a critical number. Also, if you're not differentiable at a point, that is considered a critical value. For example, if I have a function f of x equals 1 over x, let's do square root of x. Square root of x. When I take the derivative of the square root of x, I'm going to get 1 over 2 root x. In which case, x cannot equal 0. That's a point of non-differentiability. Point of non-differentiability. All right, that's what we're talking about here, not differentiable. All right, and if you think about what the graph of the square root of x looks like, you guys all know that as a parent graph. Starts at 0 and goes like that. This is an absolute minimum value right there. Okay, but it's not at the top or the bottom of the hump. All right, it's at the bottom of the graph at a point of non-differentiability. Okay, and this is not differentiable because we have too many options for tangent lines. Right, you can't draw just a single tangent line through there. All right, all of these that just touch it can be tangent lines. So, no tangent line. Quick theorem. If f has a relative minimum or maximum at some x value, let's call it c, then c has to be a critical number. In other words, c has to be a point of non-differentiability or a point that makes the derivative equal to 0. All right, so ultimately when we are finding relative extrema, we find the critical numbers, right? Set the derivative equal to 0, look for issues, right? Denominators, square roots, things you can't have. Evaluate the function, that's f, the function f of x, at each critical number. Then you evaluate the function at each endpoint. Okay, we're talking endpoints here because we're talking closed intervals. And then finally, the smallest value is the minimum, the largest value is the maximum. All right, so that's a little crash course on what absolute extrema and relative extrema is. We'll do some examples in the next video.